A custom shirt shop charges a setup fee plus an additional fixed amount per shirt. An order for 20 shirts costs $188, and an order for 25 shirts costs $228. Number 9 asks, what evidence do you see that would lead you to conclude that this is a linear relationship between the number of shirts ordered and the total cost of the order? Well, I look at this amount right here. You have the setup fee, right? Then plus an additional fixed amount per shirt. So each amount that the cost goes up is going to remain constant. So that the fact that each new additional shirt is the same amount, then that tells you that that would be a linear relationship. So to give you something to write down here instead of me just yammering, let's get the right pen. The fact that it describes a fixed amount per shirt makes it linear. And I'm going to put here it's a constant rate of change, right? That's what we're describing there. All right, identify the independent. So remember, independent is input. That's what the X would be. And dependent variables, that's the output. That's what the Y would be. So it seems to me that we have two variables. How many shirts that you're ordering, and then the cost. So let's say independent, I'm going to go ahead and abbreviate that, is the number of shirts, and dependent is the cost. And then they asked, what is the slope? What does it mean? Well, before we can find the slope, don't we need to know what our ordered pairs are? And remember, with our ordered pairs, it should be the X first, independent first, and then the Y next, the dependent. So let's look up here. An order for 20 shirts costs $188. Independent, dependent. And an order for 25 shirts costs $228. Independent, dependent. Okay, so remember your slope is y2 minus y1 over x2 minus x1, which I said was the change in y over the change in x. Okay, so I'm going to go ahead and do this point first. So 228 minus 188 divided by 25 minus 20. All right, so in the numerator that gives us 40. The denominator that gives us 5. And we get 8. So each shirt cost $8. Another way of looking at that, the change in Y, what did Y have to do with? That had to do with money over the change in X. What did the X have to do with shirt? So you can see that it would cost $8 per shirt. That's another way to look at it. All right, I'm going to create for myself some room to do number 12 up here. Okay, and it says find an equation that will allow you to calculate the cost of ordering any number of shirts. Well, we had two methods that we had talked about. One is we just use the slope-intercept form, y equals mx plus b. And so we would need we need the slope 8 and one of the points. I'll just use the 2188. So in this, we would substitute our 188 in for y equals, and then our 8 in for our slope, and then our 20 in for x. And then I see that you give, I think you see anyway, that leaves us with the b. There we go, that we have to solve for. Spit it out eventually. So I have 188 equals 160 plus b, and then let's subtract that 160 from both sides. And so I have 28 equals b. So do I have my slope of 8? Yes. Do I have my b of 28? Yes. So in my y equals mx plus b formula, I'm going to substitute my 8 in for my slope and my 28 for my y-intercept there. So we recognize that is our slope. That's our $8 per shirt. I bet this is going to be our setup fee right here. All right, so that's one method. Now let's do the point slope form. And so that was y minus y sub 1 equals the slope times x minus x sub 1. And I'm still going to use our slope of m, and I will use the same point, 2188. So we have y minus the y of our point equals the slope times x minus the x coordinate of our point. And then we're going to solve this and put it in slope-intercept form. So I have y minus 188 equals 8x minus 120. And then I will add 188 to both sides to solve for y and put it in slope-intercept form. So I have y equals 8x plus 28, which is what I had before.